It's a privilege and a pleasure to welcome Professor Venugopal Achanta, Director NPL, to the studios of Akashvani. Now, his visit to the studio should be termed as a very timely visit, as a very relevant visit, on account of two major reasons. The umbilical bond between Akashvani and National Physical Laboratory, Delhi, in the first place. Listeners would be thrilled to know, old timers would remember, but our younger generation would be thrilled to know that during your grandfather's days when you would listen to radio news, there used to be 5 to 6 pips announcing the time. NPL Delhi was the generator of those pips. And the other relevant point is, elections are around the corner. Everyone knows how important indelible ink is. And again, NPL as an institution has developed this ink and still certifies it. On that note, I again extend a warm welcome to Professor Venugopal Achanta.
Thank you very much for giving me this opportunity to come here.
I would like to let listeners know that Professor Venugopal Achanta is also an elected member of CIPM, the International Committee of Weights and Measures. Professor Achanta, how does a common person understand the objectives of NPL, albeit in the context of day-to-day life?
This is very relevant because we are talking about quality, weights and measures as you mentioned. So when we go to a shop, when we go to a mall, when we want to buy something, whether it is a quantity of any food item or any precious metals, or we need to know that quality and quantity are right. Who is going to give us that traceability? What we call traceability is from shopkeeper level to international exports or imports which are coming. Somebody has to say that yes, this is the right quality, this is the right quantity. When we are buying 24 karat gold or 22 karat gold, we need to know that it is right quality. So for example, we have this hallmarking which started recently. But this hallmarking say that gold purity. So it has to be tested against some reference materials or some known quality of material. So those are all maintained. For example, the kilogram prototype from which we make copies and then distribute across the country. The primary prototype is at NPL. The length scale, for example, is at NPL. So we set up the primary standards for the country, the national standards for the country, and we make them available through the 4 pillars, as I call it, in the quality infrastructure of the country. The NPL, the Bureau of Indian Standards, legal metrology and the accreditation bodies, we all work together to make sure that the common man gets the right quality and quantity of any material.
You mentioned it very simply. Now it seems each and every person, I think, is affected by what you do in terms of research and progress. Because be it food items or medicines or anything that you buy in the market, everything comes under the ambit. But again, that raises another very pertinent question in my mind. Physics is a very vast subject. From what you described, metrology as a branch seems to enjoy overarching status in the bouquet of NPL's varied roles in scientific research. Other areas of research besides metrology which are given equal weightage at NPL?
Because many people see NPL in a very particular role. Some people think of it as the timekeeper because we provide the Indian Standard Time. Some people look at it as the preserver of Indian Constitution because we preserve the Constitution, handwritten Constitution copies in English and Hindi. And some people see us as a metrology institute or a CSIR lab. So we wear multiple hats. As a parliament given mandate, we are the Meteorology Institute of the country. Meteorology is the science of high precision measurement. So each country has one designated meteorology institute, and for India, we are the Meteorology Institute. In addition to that, we are part of the CSIR family. We are the first among the first 5 laboratories, CSIR laboratories, which were established. So that way NPL is little older than independent India. So we have been contributing to the metrology. But as a CSIR laboratory, we also contribute to the industrial research, to what we call the service projects, where if there is an industry is interested, want to find a solution to their problem, we address those challenges for the industry. For example, you mentioned indelible ink. That is one of the challenges given to NPL way back in 1949, around that time. So then the chemistry unit was formed in 1949, and within 2 years the ink was developed, and it's almost like the entire ink needed for the general elections in 1952 and 1957 were actually produced in NPL, the chemistry unit. So that way, so we do industrial research. Then, being the only physics lab, defined the physics mentioned in the name itself. So we also do considerable amount of basic R&D. So we do metrology, we do material science, and the old legacy, so we have this radio engineering or radio electronics, which is another large area. Predominantly, we work on environmental sciences. So that old division, so now it contributes basically for monitoring the environmental pollutants. So for example, right now, after 1960s, we are doing the mapping of noise across Delhi NCR region at around 170 locations across Delhi NCR. So that this helps in policy making for noise related issues. So we work with all relevant ministries, the Minister of Environment and Forest, CPCB. So we partner with them to do what is right. So mapping of what kind of firewood being used across Delhi NCR, right? And what are the pollutants which come out and how they travel across these regions. So we do all these kinds of basic as well as environmental monitoring related studies.
Metrology is a word that's very close in sound to meteorology. Do you have a presence in meteorology as well?
So meteorology is the weather prediction. So we do in environmental sciences, for example, we have what is known as it's like a sonar, or the equipment name doesn't matter, but we ping these sound waves to the ionospheric region and then we continuously monitor. We have decades old data of how the ionosphere is behaving every day, like every few minutes we ping and check it out. So all this data is useful eventually to understand how the ionosphere is changing over time and what are the conditions. So if we want to design some radio wave transmission or transmission of even the satellite launch. So the satellite movement depends on the conditions of the ionosphere. So we provide these data to all the relevant stakeholders, whether it is ISRO or meteorological departments, so that so they use this in weather prediction and satellite rocket launches, then even transport of aircraft. So all these things we contribute.
Professor Achanta, you mentioned indelible ink and then material science. Now, for the ignorant mind is bound to be slightly cloudy now. Where do physics and chemistry overlap and where do they separate? You mentioned chemistry also.
So a good metrology institute will have no designated line that I'll only work on this, right? So we do have very good physicists, we have very good material sciences, we have very good engineers, chemists, biologists all together working. So because we have different challenges, if we want to deliver the right solution, we need to work together. So it's a very interdisciplinary area and we all work together.
Professor Achanta, out of this text comes to mind, for a common reader of books on science, it seems that a lot of physicists have also been mathematics. Now, what I want to know is, are there examples where it has been the other way around, that core mathematicians have also been physicists?
Yes, of course, there are many people like the physicists turned biologists, right? So we have all kinds of examples, yes.
Tell us about the latest developments at CIPM, International Committee of Weights and Measures, since you are an elected member of that. What are the activities and achievements of that?
So we meet quarterly at the BAPM headquarters, which is in Sèvres in France, in the suburbs of Paris. So what we do is the structure of this entire weights and measures is that it started in 1870s. Then 19 countries were initially members, initial signatories, and then what they said is there is a CGPM, which is all the member countries, so they meet once in 4 years. Now they make the final decisions. Everybody votes, every country votes, and then decisions are made about what is the future for the 7 international system of units, the SI units, what we call. So what are the new things, what we should do? For example, time we know as what we currently use is some energy levels within transition in cesium atoms. So this is in the radio frequency. This is about 9 gigahertz frequency. Now going forward, we want to increase 10 power 9 hertz. So now if we take transitions in ytterbium or some other ions or atoms, So where the transitions can be in the optical domain. So that is in the 400 to say 800, 750, 800 nanometer range. So here the frequency goes to 10 power 15 hertz. So now from radio frequencies, we are going up to optical frequencies. So our precision with which we can give time will increase by at least 3 orders of magnitude. So these are some very specific elements. These are called Rydberg levels, and so these are used, and they have very long lifetimes and much more stable than other atoms. So, but which atom to use? Like, so there are some representative atoms which people are ions which people are working on in different countries. Different ions people are looking at. So we discuss what is the progress happening across the world, and can we give recommendation to the next CGPM, that's the general body, and about, for example, which ion or which optical transition we can recommend for everybody in the world to follow. Similarly, like how do we measure mass? How do we measure the mole quantity of material? So these are all 7 SI units, and how we can improve the measurements, how we can look for the future. So things are changing. So the way we are disseminating information is changing rapidly. So how do we take care of these things? So we need to look at digital metrology. There should be low human intervention so that there's no question of manipulation of the certificates which are issued. And there should also be, anybody wants to check whether it's a genuine certificate or not, they should be able to get that information. We are having blockchains, we are having different kinds of technologies which are coming. So how do we adopt these to the SI units and their definitions as well as dissemination? So we discuss these things, formulate way forward, and give the recommendations to the CGPM.
Sir, you mentioned such high level of advanced research. Now, will it translate into something for the common man besides experts?
Absolutely. For example, what we are making, it will directly go into, we are developing technologies or taking up technologies which are mature or evolved over the last few years very rapidly, and then where we can adopt them to do high precision measurements. So these can all go into the development of the local industry. So these are eventually go there in the production as well as quality system of these industries. So, and then eventually translates into the quality of the products which we are using. So that way, like, yes, I mean, these are, it's a traceability, it's a long chain where everything is connected to eventually to the quality of our own life.
Professor Achanta, let's now look at the other end of the spectrum. If you look at the last, say, 5 years or so, what have been NPL's achievements in helping people out with ease of living, but at the absolute grassroots level?
So to impart our knowledge and to inculcate the scientific curiosity among younger minds, what we do is we are open. The last Thursday of every month, we are open to schools, colleges, in any education institution, whether it's private or publicly funded, so they can come and visit us. Then we organize several open days in addition to this, and we are quite flexible. Though we have defined this, any school, for example, far away from down south or up in the north, like so school in Jammu wants to come, or a college in Kerala wants to come, and they say that like we have a date constraint, we just open on that particular day for those students. So we organize a PG diploma course, a 1-year PG diploma course in precision measurement and quality control. So these are absorbed into the industry. So we have these accredited laboratories across the country. So these are very well accepted for their quality and for the training. We give both hands-on as well as theoretical training to each one of them, how to calculate uncertainty, how to measure, and all these things. So that way, like, so we do considerable amount of science outreach for the general public, so that we take the curiosity forward to the next generation.
No, I was also referring to, developing things like new materials, for example, because I went through the tile story and I was pretty impressed with that.
Thank you for pointing it out. Yes, waste recycling is one of another pioneering work at NPL. So plastic waste recycling to tiles is very well matured. We have transferred to almost 17 industries so far. So they can use our process to use the waste plastic to usable products. They vary from, say, movable toilets, right, to road tiles, right? So currently we are working on tiles which can be used in extreme cold to extreme hot temperatures. In temperatures up to 50 degrees, we tested these things and they work pretty well. So, and now we are working, so our tiles, which we work with our sister lab, the Road Research Institute, CRRI in Delhi. So we are looking at can we use it at minus 20, minus 30 degrees centigrade. So extreme cold places, like, so can we use our tiles, and what kind of improvisations needed? For example, plastic, we know we have the molten plastic which we can generate, but then the binders which are there, like, so that need to withhold to those temperatures so that they don't crack at extreme temperatures. So the current technology which we have, materials which we have, will withstand up to minus 15 degrees centigrade. So we're trying to push it forward. Another interesting, important aspect is which happened in the last year and a half is the government has strong push for renewable energy. Solar energy, photovoltaics is one of the major areas, with a target like 50 gigawatt installations per year is what the government is targeting. Now, these solar panels are huge, massive structures, and they have large amount of silicon inside them. Now, they have certain lifetime, say 15 years, 20 years. After that, this is going to be a waste. So far, the solar panel recycling only is focusing on extracting the precious metals, whether it is gold or platinum or silver or the epoxy which is used, the glass which is used. So because these are specialized things. But what nobody concentrated or thought about now is the silicon itself. We are getting tons of silicon waste. What to do with it? We developed a process and we could get, it's like we call in terms of number of nines, 99.99 is 4N purity. So we could get about 5-9 purity silicon from these old silicon panels. So this can be reused in electronics industry eventually. So that is what we are trying to see, that like, so the whole idea is to have a circular economy, so that we develop the materials and then we should be able to recycle them so that we leave less waste for our future generation.
Professor Venugopal Achanta, what is your advice to young listeners in their dilemma in choosing basic science versus technology?
So the basic science understanding is very, very important. Without that, no technology will exist. So if you talk about any X, whether it is electronics or photonics or whatever, the technology came from understanding of semiconductors, understanding of basic material science, understanding of light, properties of light, how light interacts with matter. So the basic science is always and will always be evergreen. So without understanding basic science, without having strong fundamental understanding of science, very difficult to achieve strong translational research which will go into products or technology of the future.
Professor Venugopal Achanta, thank you so much for sparing time for our listeners. You came all the way to the studios of Akashvani. Thank you very much.
Thank you.